Okay. Okay, welcome back. What I want to look at is direct current DC circuit theorems, current sources and EMF. Okay. Now it is important that you understand what the above are, as it is important that you know what EMF and current refers to. An EMF, denoted E or E, is an ideal voltage source with no internal resistance, so the voltage does not change with the current drawn from it. The current depends only on the load connected to it. Okay. Now remember, it is the ideal not to have an internal resistance, but as all EMF will have some internal resistance of some sort, we will always need to calculate that internal resistance to determine its value. The current or the voltage will not change irrespective of what load is applied. Thevenin's theorem. Thevenin's theorem is used to simplify a resistance network with voltage and current sources within it. We replace the network with a single EMF E and a resistance RT in series with it. Now this is like replacing the network with a battery that contains internal resistance. The following diagrams illustrate the equivalent circuit. Okay? And here's our diagram. Okay? Vs, source supply, R1, R2, R3, and your output. Okay? And I call this diagram T1. Okay? In diagram T1, resistor R1 is in parallel with R3. This is the parallel network that needs to be calculated first. We now need to show the calculations and the equivalent circuit after the calculations has been done. Now A and B is open circuit. This is where the current source would appear and the load resistive or otherwise. The calculations first to solve the parallel circuit. we're going to use Rp equals R1 times R3 over R1 plus R3, product over sum. Once we have found the parallel network, the value of the parallel network is then added to R2. The formula then becomes RT equals R2 plus R1 times R3 over R1 plus R2. Now the following diagram shows the equivalent circuit and relevant calculation formulae. This is the equivalent circuit for T1. And here we are. E, V out, and 1 RT total resistance. Okay? Equivalent circuit for diagram T1. Okay? Now here RT equals the total resistance of the circuit. E equals the applied EMF. A and B equals the output. To determine RT, we evaluate the resistance as seen at the terminals A and B, with the voltage source replaced by a short circuit, as shown in diagram T2. Alright, let's look at diagram T2 first, make sure I can find it. Bear with me for a moment, I just wanted to see whether I was ahead of myself or not. Okay. That's okay, I was ahead of myself. Okay. To determine RT, we evaluate the resistance as seen at the terminals A and B with the voltage source replaced by a short circuit, as shown in diagram T2. And here's diagram T2. I just wanted to be sure that I was looking at the correct item. Okay. I couldn't remember if it was ahead of me or behind me. It's behind you. Okay. Now current sources are open circuit. The voltage at the pairs at A and B is constant, so the current drawn would depend on the load applied across A and B. Let's just look at the calculations required to deduce the network. We need to calculate the parallel resistors first. Again, here we have Rp equals R1 times R3 over R1 plus R3. The next stage will then be to bring R2 into the equation. Similar function as before, okay? Let us now look at the circuit as a whole, okay? Taking into account current, voltage, and where there is a current flow. There's no current flowing through R2 because only R1 and R3 that makes up a current flowing circuit. Okay. I equals Vs over R1 plus R3 equals E equals VOC equals I R3 transpose for E. VOC is open circuit, voltage open circuit, okay? E is the voltage that appears as the input voltage, taking into account the resistance in the circuit. This is the formula that you will need to apply, okay? It would be the voltage appearing across R3 as measured at A and B, okay? Let us look at an example. I will take it step at a time. Work example 1. For the circuit shown, find the values in Thevenin's equivalent circuit. If a load of 10 k ohms is attached to terminals A and B, what is the current drawn and voltage? Now here are your values, voltage, your values of your circuits, okay? I hope you can see them, okay, yeah? Yeah, okay. Okay. This is diagram T3. How to apply the solution? 1, we determine the parallel circuit first. 2, this would consist of resistor R1 and R3. 3, we apply the formula as previously given above. And that's your process that you'll need to apply, okay? I'm not going to go through that with you again. You can now do this for yourself, okay? Okay, you can see that the answer is 30.913 kilo ohms, okay? So, we now have the total resistance of the circuit, but remember we were given a load of 10k, so this has to be added to the total value. Remember the load is across A and B. We need to find the voltage using the formula. And here we are. E equals R3 Vs over R1 plus R3. We know I equals V over R. Then I've done something here simultaneously, together. Okay, so bear with me, but you now need to follow this and apply the calculation for yourself. Here we're looking for I, okay, based on information that we have already been given. And you can see that here that 0.238 milliamps rounded up. Okay. Now make sure that you can follow this section here, okay? You know where these come from and why these are the numbers that they are. I just simply employ the shortcut as I've done it already. But here we're looking for I. And you got to look at where this came from and where this came from, 40.913, okay? Be sure you know where those values are. We know that V equals I over R. V equals I times R, 2.38 volts, okay? So here, Remember, it is 0.238 milliamps and milli is a thousand. So if we remove 3 zeros from the 10, it would leave us with a numerical 10. When we multiply 0.238 by 10, it gives us 2.38 volts. Or you can just simply multiply it as we did above. Okay. Okay, thank you. I hope you found this useful. Let me just work my way up now and recap all. Okay. Okay, thank you. Have a good day. Bye-bye.